Hey everybody, this is Larry. This is day 9 of the Leetcode January Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about today's farm. So I did a little bit poorly this morning in New York time anyway. I know that some of y'all are from the time zone in which, that's like at night for you. But anyway, I did poorly, so hopefully I get to redeem myself in a later contest in like about 2 hours and also in this problem. Anyway, today's problem is robot bounded in circle. Let's see, what does it say? Okay, so it's a 000. G goes straight for 1 unit, turn left, right, okay. True it exists in a circle such that the point never leaves the circle. What does that mean? Remains in it. It repeats them forever. Okay. I missed the repeating them forever part. Okay, so the only way that this doesn't, so I think the only way that sometimes for these problems for me is to think about the opposite of the problem is that, if it goes on forever, that means that there are really only two cases though, right? One is it's stuck in a forever loop of like it just, I don't know, keep on going in a circle, right? Which is actually what the answer is asking for. And if not, that means that every iteration, if there's a delta, if it changes, every iteration, it's going to, what was I going to say? Every iteration will move you slightly away from the place. Actually, now that I hear myself, is that slightly not true? There's actually, I think you have to run it, and this is from experience, from like symmetry, kind of playing around with it, is that you have to simulate it 4 times. And if you do it 4 times, you're either back in the beginning or you have an offset, right? And what I mean by an offset is that, for example, if you start at 0, you simulate it 4 times, and then you're like 1 step up. Well, if you're going to keep doing it every 4 times, every 4 iterations, you're going to keep on going up, and therefore it will always be in a circle, right? So that's basically, it will always be outside the circle because given an infinite instructions, you'll always keep on going in that direction, right? And why do I say 4? 4 is because there's some symmetry with it doesn't have to be 4. It could be either 1, 2, or 4. 1, 2, or 4, because there's something about the symmetry about turning left and right? Because for example, you can imagine that I'm like a little bit hand wavy, but you can imagine that you do a series of instructions and you end up like, let me actually, I'm trying to think whether I should paintbrush it or ASCII art it, but let me just paintbrush it real quick. So for example, you can imagine that, let's say you're starting at this square, and you're facing this direction, and then after the first iteration, maybe there's like a horse, not a horse, but a knight, right? Like a knight-like move where, for example, this is one case where you go one, so initially it's facing this way, and then after one iteration of the moves, you do something like this where it goes 1 to the left. I mean, it doesn't have to go in this direction, but let's say, and it goes maybe this way, right? And then if you do it again, and this is just something that's from experience, right? So if you do it again, maybe you have something like this where now you're here, and then now if you do this again, now you're here, and then now you can see that in this case, after 4 moves, you're going to be in the same place, right? So in that case, you're good again. And of course, there are, there are other type of symmetry, right? Where or there's a 2 symmetry where after 2 iteration, maybe, like just a very simple one, for example, is something like, let me use it. Let's say you have a series of moves that begins going here, and then after 1 move it goes here, and then again, there's this rotational symmetry where after two iteration you're back at the same spot. But 4 is the max, right? You cannot get to a place where there's more than 4, or even 3, but or cannot be 3 exactly, can only be 1, 2, or 4 symmetry, and that's basically and of course if you simulate it 4 times, that will be good. So that's basically the idea here. It's kind of try to figure out a way such that you can get back to the beginning thing. And of course, there's a much easier example here. This is just me kind of, I guess, I don't know why I came up with this example, but I guess a very basic example is just like a 4x4 thing, right? Where initially maybe, you know, you start here and then next you're doing here and then so forth, right? Anything that has, you know, there are a lot of ways to do it, but that's basically one thing that happens, right? So basically, my idea would be here just to brute force doing it 4 times, and then if it's still doing the same thing, or if it's facing north from 0, 0, well, it has to face north if you do it 4 times, because no matter what the initial income is, or no matter what the input is, if you do it 4 times, it always faces north. Then the question is, and you could prove to yourself why, because you can just enumerate all the possibilities, right? And then after that, it's just about seeing where the robot is, which is whether it is at 0, 0. So, okay, let's get started. The three that I would like to start is kind of set up the directions. And then first, let's do north. North is, and you, as long as you're consistent with your definition, is okay. But for me, north would be going up, which means up, up on the x-axis. That means that we don't change on the other one. And then, so this is north, and then turning. So we want to do a rotational thing. So maybe we'll just keep right. So right would be 0, 1 for me anyway. You, like I said, as long as you're consistent, it's okay. And then this is down, and then this is left. Oops, I got it wrong a lot. Maybe because I'm talking. That's my excuse. I'm sticking to it, right? So that means that here, the reason why we do it this way is so that we know that when we want to turn to the right, this is just, you know, this going to the right, to the right, to the right, and then, you know, it loops back. But that's basically the idea. And then of course the opposite of that, turning left, is just going up from here, going up, wrap around, up, 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 and then so forth, right? So that makes it a little bit easier. So then now we just have to do it 4 times, like we said. For instruction in instructions, and of course we can actually also I messed up a little bit, but yeah, let's set x y is equal to 0, 0, as we said. It doesn't really matter as long as you get it from the beginning, but obviously 0, 0 is easier to do. And then the direction is equal to. And actually, to be honest, it really doesn't matter. I mean, here, because we want to be precise and consistent, just in case there are changes that we have to make, it actually, I'm going to make this 0, as we're saying, because we're pointing north, going up. But that said, in this particular problem, it actually doesn't matter, because by the argument of symmetry, like if you start facing north, it doesn't matter if you're facing south. It's just everything's the same except for in the opposite direction, right? So there's some like rotational symmetry there. So it doesn't really matter actually, as long as you're good about it. Okay. So then now, if instruction is equal to g, then xy is equal to x plus directions of oh yeah, wow, that is the direction. Or maybe another way of writing it will be dx dy is equal to this, and then y plus dy, right? And that's pretty much it for this instruction. And then otherwise, this is left. If this is left, in this case, we're going to do, you know, a direction -1 plus 4, if you want to. I mean, I know that Python has a thing for negative mod, but I just wanted to be clear for the languages as well. And then otherwise is this. And of course, again, there is some symmetry here. So technically, you could get this wrong and still, like you can make a mistake and it'll still give you a right answer. But, you know, try to do the best you can and make sure that you're right on this one. Right, and then after this happens 4 times, we just have to check if x is equal to 0 and y is equal to 0, right? We just have to return this, and that's pretty much it. Because if we're in the same place, then we should be good. We also want to assert that, just for me anyway, because I said that this is true. So let's actually see if this is true, that after 4 iteration, they'll always be facing north. But yeah, I think this should be good. Let me actually make sure I answer the question, because I always forget. So, okay, yeah, return true if it never leaves, so that's good. Let's give it a submit. So yeah, so this looks good. Let's give it a submit. I do believe I did this during contest, but I could be wrong. Yay, 649. Yeah, and this is going to be linear time because we just do this 4 times linear. There's really no, we use all of one memory pretty much. So yeah, don't really have much to say about this one. Yeah, it's just about simulation, and a lot of them, after you kind of understand a lot of the proofs and maths and the symmetry, this is pretty straightforward. Of course, that's a big caveat. So yeah, let me see what I did last time. I probably did about the same thing. Yeah, okay. Roughly the same thing, give or take. But yeah, and we don't even have to go back to. I guess this is a possibility for early termination after one set of operations, but it's not really necessary, as we kind of talked about. So I guess this time I did more math than I did last time. I think that was during a contest though, so I could be wrong. Let's see. Did I not do this during a contest last time? So maybe I was wrong. Maybe I didn't do it. Maybe I did a similar problem during a contest. Okay, maybe I didn't then, because I think if you did, and you click on certain things, it takes you to the contest page or something. I could be wrong. But yeah. Yeah, linear time, constant space. That's pretty much all I have. Yeah. Let me know what you think. Stay good, stay healthy, to good mental health. Good luck on your contest later if you're doing it. If not, just have fun and have a great weekend. I'll see you later, and bye-bye.